Good morning. For those of you who missed the math session, I wanted to go through and help you with sections 3 through 4 in scientific notation. We went through in our meeting earlier about just how to convert to and from standard and scientific notation, but we're going to get to actually doing some math. And so I want to make sure that you have a chance to look at this video and be able to pause it as you go. So if you're still working on the math, I would suggest I'm going to go through in order. So I would suggest listening to this lesson on adding and subtracting numbers and then be doing it in IXL and only go one section at a time because there's a few different tricks for each type of math. So I want to make sure that you pause and don't get overwhelmed by listening to all of it. So I'm going to go ahead and pull up section 3, add and subtract numbers written in scientific notation. And I'm going to remind you that if you're on your own and you don't remember how to do it, anytime you start a new section, there's this learn with the example, but it's only when you just start. So make sure that when you start a new section, if you're not sure how to do it, you're not just guessing and you can go to learn with example. Okay, so we can look down here. And this, for me, this is the most helpful because sometimes when I start reading the key idea, I can get confused by the math jargon if there's something that I'm learning. So I'm more of a visual learner. I want to see the problem played out. If you are more of a words person, sometimes this key idea can be really helpful. But a lot of times I will switch just to the solution. And so basically what this is showing us is that if both of the scientific notation sections have the same exponent, they both have the same power of 10, you can use the distributive property to just add them and maintain the same exponent. So the only tricky part in this is if there's two different exponents, but if there's the same exponent, then all we're doing is just adding the base number, the 1.34 and the 6.521. And I suggest using a calculator when you're doing any sort of addition with decimals, especially in IXL, because it can push you backwards in IXL just for missing one question. And I never want you to be in that situation. So what we're going to do, I'm going to do the exact same question. I'm going to write it down on my piece of paper and then I'll show you how I would do it. 5.83 times 10 to the 4th. Here, let me switch over to my other camera. You guys can just see me as I write it. It might be. Okay. We have 5.83 times 10 to the 4th minus 1.22 times 10 to the 4th. Okay, so we can use the distributive property. These two are the same, they're multiplied by the same power of 10. So rather than having to do each set, so you don't have to solve each set of scientific notation. This is kind of very similar to having like terms in fractions. We want to make sure that this has the same power of 10 and this has the same power of 10. It already does, so we can do the math. So all that this turns into is 5.83 minus 1.22 times 10 to the 4th. Okay, so you can all do that math. I'm going to use a calculator because I always like to double check. I'm also a little bit of a perfectionist when I'm trying to do my work. So if you're like me and you get frustrated if you get a wrong answer, sometimes taking that extra time to just make sure that you've done the math can make it really helpful for you. Sorry, I have too many things going on my screens. So we've got, I did 5.83 minus 1.22. I don't know if you can actually see my, oh yeah, there we go. I'll start from the beginning. 5.83 minus 1.22 equals 4.61. So then my answer is just going to be 4.61. And then you just keep the same bit of scientific notation. 4.61 times 10 to the 4th. Okay, so let's do one where the exponents are not the same, okay? Because that gets a little more tricky. I will say also it's the same exact thing if this were addition. So if this had been addition and it was 5.83 times 10 to the fourth plus 1.22 times 10 to the fourth, we're going to do the same exact thing. We're just going to use our distributive property and we're going to keep the same power of 10 and have 5.83 plus 1.22 times 10 to the fourth. Okay, so this step is still the same on both sides. You're just using addition instead of subtraction. Okay, so if I was doing that, sorry, my phone wants my Face ID. If I was doing that, I would do 5.83 plus 1.22 equals 7.05. So I've got 7.05 times 10 to the fourth. Okay. So what happens? There's two things that might happen when we're doing this that we need to be aware of. One of those things is that maybe when we start, our exponents aren't the same. Okay. So let's try it if our exponents were not the same. So let's say we have, I'm just going to make one up, 1.65 times 10 to the fourth, excuse me, plus 3.8 times 10 to the second. So now we can't use our distributive property because we have two different powers of 10. The fastest way to fix this is just to get to the same power of 10. So if we can make it so each of the tens is to the same power, then we can do the same process we just did before. The easiest way to do that is to take your higher exponent and bring it down. So we want to make it match this exponent and get it to 2. So if we know we're going to make this one into a 2, we can leave this one over here the same. 3.8 times 10 to the second. So what we need to do here is move the decimal. We want to get the 4 down to a 2, so we need it to be 2 less. So we need to move the decimal 2 down, okay? So instead of 1.65 times 10 to the fourth, it then becomes 165 times 10 to the second. Now we have matching powers of 10. This is correct because we've used what we've learned about exponents to move the decimal. So now we have 165 plus 3.8. The powers of 10 remain the same. So if I do this one, I could probably do in my head 165, 166, 167, 168.8. So my answer is going to be 168.8 times 10 to the second. Now, this is the last example of something that could throw you off in this. If you remember when we were learning how to do our exponents, we know we can only have one number in the ones place on the left side of the decimal if we want to write something in correct scientific notation. We were able to kind of cheat the rule here so we could do the math, but to get our solution, we have to put it in correct scientific notation, which means we have to get this decimal here because we can only have one number in front of the decimal. So we're going to use what we know about scientific notation to move this decimal 1, 2 over. So now we have 1.688 times 10. Well, it was 10 to the second power, but we moved the decimal 2. So 2, 3, 4. We have it back to 10 to the fourth power. Sorry, there's sun shining right there. So that is what you'll do. Anytime you get an answer that has more than one number in front of the decimal, you have to fix it in your solution. You'll get the answer wrong if you type it in this way. You have to make sure you do the final step to put it in correct scientific notation by moving the decimal to just behind the first number. And then anytime you move a decimal like that, you need to make sure you update your exponent. All right, now that we have done addition and subtraction, we're going to move into multiplying and dividing. We're going to use a lot of the same skills we just practiced, but first we're going to go into multiplication, okay? So we're going to get a question like this. I'm going to show you the two different ways that multiplication is going to be written out for you. So this first way, 3 times 3 to the 10 to the third, sorry, 3 times 3 times 10 to the third. All we need to do is multiply the two numbers here. So we're going to get 9, and then we keep the same power of 10 to the third. Same thing here, 8 times 5 times 10 to the fifth. 8 times 5 is 40. And if you remember, let me switch to my other camera. If you remember, we can't have two numbers in front of the exponent. So I'm going to switch over to my camera and talk about that really quick. So we have 8 times 5 times 10 to the fifth. Okay, so we can keep our scientific notation number. That one just hangs out. All we need to do is multiply 8 times 5. 8 times 5 is 40. And then we have times 10 to the fifth. Well, we can't have two numbers in front of a decimal. And we know that any rational number here just has a decimal at the end, even if it's not written. So we need to move that decimal 1 over to get 4. And then since we moved it 1 over, we need to add 1 to the exponent. So we have 4 times 10 to the negative 6. So if you, not negative 6, oh my goodness, 4 times 10 to the 6th. My apologies. If that's something that you can hold in your head, you can kind of do it on your own. If that feels like too many things to hold on to, you can write it down the way I just did each time. And that can help you get into the habit of learning how to do it. I'm going to show you, I'm looking at IXL, just I want to make sure I go through the different types of problems. And let me get this out of the way. The next one is a little bit more tricky. We're going to have, it's written like this, 4 times 10 to the fourth times 2 times 10 to the fourth. If you remember, when we were doing addition and subtraction, we talked about them having the same power of 10. In this instance, they have the same power of 10. So all you're going to do is multiply 4 times 2. So then you end up with 8 times 10 to the fourth. Just the same as we did with addition, if they're different exponents, then we have to switch it into the same, to having the same exponent. So if we had 4 times 10 to the fourth times 2 times 10, let's say 10 to the fifth. Now we can't use the distributive property because our powers of 10s aren't the same. So just like in fractions, when we make like terms, we're going to turn this into a 4 so we can do the math and do the distributive property. So if we know we're going to take our higher number and turn it into our lower number, so we're going to keep 4 times 10 to the fourth, and we're going to multiply that by, we want to move this 1 over, so we're going to take 2, and we know there's just infinite zeros after a 2, and that we know that the decimal is there. It's implied, even though it's not written. So we're only going to move it over 1, because to get to 4, we only have to take 1 away from 5. So we're going to get 20 times 10 to the fourth. Okay? because we needed to make this exponent the same as this one. So we used what we knew about writing in scientific notation to move the decimal and change this exponent. So now we can do the math super easy. We're doing 4 times 20, which anytime I start doing math, especially when I'm doing it on a video, I always double check. I should be able to do 4 times 20. There we go. Because it also is the same as 4 times 2, add a 0. But anytime you're feeling nervous, like you maybe won't get it, always use a calculator. It's part of just making sure we're doing it correctly, okay? So now our answer is gonna be 80, and we're gonna keep the same because we have the distributive property, times 10 to the 4th, okay? Now, you know we can't have these two numbers in front of this decimal that's here, that's implied. So we need to move this decimal here to right after the first number. So the number we're gonna get is 8. We don't have to write the decimal. We don't have to write the 0. Those are just implied. But since we moved it 1, we need to add 1 to the exponent. So your end number is gonna be that. So you're doing this, it's very similar to the addition and subtraction you were just doing, except now you are multiplying the numbers, okay? So the next step we're gonna do is division, and I wanna get to that really quick. So let me stop sharing for just a moment, and we're gonna move back in IXL. I'm just getting it pulled up really quick. Into dividing in scientific notation. Dividing is a little bit different. You don't have to do any of the changing that we did in addition and subtraction. So let me pull up IXL so you can see it real quick. Okay, you're gonna see numbers like this, where you're gonna be dividing two different numbers that are in scientific notation. Again, you can always click on Learn with Example. This is a new system from what we were just doing, so I wanted to show you what it said in IXL. So what we're gonna do when we divide two numbers in scientific notation, this is actually a whole new system from what we were doing before. And it's pretty simple once you get the hang of it. You're going to divide the base numbers, and then you're gonna take your powers of 10 and you're going to subtract the bottom exponent from the top exponent. So I'm gonna put this in my, on my paper really quick. 3 times 10 to the 3rd over 3 times 10 to the 2nd. Okay, and we're gonna do that over here on my screen so I can talk through the steps. We're switching cameras really quick. Okay, so the first thing that we're going to do is group the factors here and the powers of 10. We're doing two different equations. The first thing we're gonna do is we're gonna do 3 over 3, and we're multiplying that by 10 to the 3rd over 10 to the 2nd. That's really what it equals down to. That's what you're doing. So that's stuff we've done before. But what it's gonna look like, 3 divided by 3 is 1. And then we're gonna have a 10 to an exponent, and when we divide numbers with exponents, all we do that are the same, all we do is subtract the bottom exponent from the top. So we're getting 3 minus 2, which equals 1. There will be positive and negative answers, so you'll start having negative you'll start having negative exponents. So if you're stressed out about your math and getting that answer right, so if you had, for example, if you had, let's say it was 3 times 10 to the negative 3 over 3 times 10 to the negative 1. If you're forgetting how to subtract -1 from 3, check on your calculator. It's okay. We practiced at the beginning of the year adding and subtracting negative numbers, but sometimes our brains just get a little funky. So if you're not remembering the rules, go ahead and double check on your calculator, because it's one of the multiple steps that you have to get correct. Okay, so you're dividing these and you're keeping your exponent, your power of 10. And then if you're feeling nervous about your answer, you can always just go, and in my calculator, I wanted to show you the negatives really quick. That's why I brought that up here. There's a bad reflection. So on my calculator, you need to push the number and then the negative sign to make it a negative number. Some calculators, you can push the positive and negative sign first and then the number. So make sure you know how your calculator works and where the button is to make it positive or negative. So -3 minus, have the minus highlighted, and then I'm gonna subtract 1, but that 1 is negative. So it feels a little backwards from how you say it, but that's how you do it. So my number is -2. So my answer is 1 times 10 to the -2, okay? So same rules apply if you get a number, if your answer, your number that you're dividing is larger than 9. So if you had like 10, if your answer that you got to was something like 10 times 10 to the 3rd, you know that your decimal's here and you need to do that final step of moving it over to get it in correct scientific notation and change your exponent. So don't forget to do this step if you get an answer that is bigger than 9. Okay, so that's a breakdown of how to do each step, and I'm going to be around today. I am available to do a math session at 3, so if that's something you would like to do, please let me know. And make sure you go through, oh, you've already listened to the whole video, so good job. Let me know if you have any questions.